Frisby test is a test of stereo acuity or depth perception. We are not always able to tell when two objects are in different depth planes. The point where we're just able to tell when two objects are in different depth planes is called the threshold. The stereo test, like the Frisby test, is a measure of this threshold. During the Frisby test, a plate with 4 blocks of assorted shapes is shown to an observer. One block contains shapes that are in different depth plane than the other shapes on the plate. The observer must try to identify which block contains these shapes. 10 trials are conducted by rotating the plate so that the block containing the shapes in a different depth plane are in different locations. The observer should close his or her eyes while the plate is being rotated so that he or she cannot track the correct block. For each trial, the observer's response should be recorded as correct or incorrect. The test is performed at several distances. Start with the observer at 25 centimeters from the Frisby plate. Then repeat the test at 50 centimeters, 1 meter, 1.5 meters, 2 meters, 2.5 meters, 3 meters, 3.5 meters, and 4 meters. After the test has been administered at all distances, you can plot the data as a function to find the observer's threshold for stereo acuity. The Frisby test is a forced choice test. Even if the observer cannot tell where the correct block is, he or she must choose one block. The probability for guessing correctly is 25%. The threshold is the stimulus intensity that can be detected at a rate between the guessing rate and 100%, which is 62.5%. Let's see a demonstration of the test and plotting the data.
Okay, so this is the demonstration of the Frisby test.
Lower right.
Right.
Upper right.
Good.
Nope.
Open.
Lower left.
Good. Close. And open.
Upper right.
Right. Close your eyes. And open.
Upper left.
Right. Close your eyes. And open.
Lower right.
Right. Close your eyes. And open.
Upper right.
That's correct. And close your eyes. And open.
Lower left.
Correct. Close your eyes. Open.
Upper right.
Close your eyes. And open.
Lower right.
So the test contains 6mm, 3mm, and 1.5mm plates. For this lab, either the 3mm plates or 1.5mm plates can be used for data collection. Once you have completed all testing, determine the percent correct at each distance. This is the value that's going to go on the y-axis as shown on the graph. The x-axis will contain your test distance starting with the greatest distance, since this is below your threshold. So this is what the graph should look like when everything has been plotted. As you can see, the threshold is 62.5%, on the y-axis is percent correct, and on the x-axis is threshold intensity. The test distance that correlates to 62.5% is the observer's threshold. We then use the distance to calculate the disparity using this equation. In this equation, the disparity equals 206,264.81. That's multiplied by the plate thickness in centimeters times the patient's PD in centimeters, and that's divided by 1.49 times the viewing distance squared. And this value that you get is your disparity, and this is your observer's stereo acuity.